Convert 255 grams to pounds, given that 453.6 grams equals 1 pound. In this problem, I start with 255 grams, and I have to convert it into pounds. In order to do this conversion correctly, I need to multiply the 255 grams by a factor that has grams in the denominator, so grams will cancel out, and pounds in the numerator, so my final answer will come out in pounds. That factor set up correctly is 1 pound over 453.6 grams. Notice that in this problem, the number 453.6 goes in the denominator. Don't become psychologically tuned into always wanting the number to go in the numerator. It needs to go wherever it properly should be put. Sometimes that's going to be in the numerator, and sometimes that's going to be in the denominator. Doing the math, you obtain an answer of about 0.563 pounds. Now let's look at a problem that will involve more than one conversion factor. Convert 26.3 miles to centimeters, given the conversion factors that you see on the screen. As I said, this problem is going to involve a number of factors. I'm beginning with the quantity 26.3 miles, and I want to convert that into centimeters. Now, what I would really like would be some sort of a conversion factor that would have centimeters in the numerator and miles in the denominator. If I knew this factor, then I could do this problem in one step. But I wasn't given that factor. Since I wasn't given that factor, I have no choice except to work with the factors that I was given. So where should you start? The only factor you were given that had miles in it was that there were 5,280 feet to a mile. So you're going to have to start there. I must cancel out the units of miles. They are not in the final answer. So I used a factor that will do this. This factor was 5,280 feet per mile. This, however, will only give me my answer in feet, not centimeters. By the way, I assume you realize that miles and mile will cancel each other. The fact that there is the letter S in one word and not in the other doesn't mean anything. Now, some of you may want to actually multiply this out at this point and get your answer in feet. That's okay, but I don't recommend it. Do it if it makes you happy, but it's not necessary. I now have to multiply by another factor that will get rid of feet. That factor has to have feet in the denominator, and that factor is 12 inches per foot. So I multiply by this factor, and this would produce an answer in inches. I am almost home. My ultimate goal was to convert this measurement into centimeters, and now I can accomplish that because I now have a factor that has inches and centimeters in it, namely 2.54 centimeters per inch. Now I just get out a handy-dandy calculator and punch in the numbers. The calculator tells me that the answer is 4,232,574.72 centimeters. Remember that the next time you run a marathon, you are running a total distance of over 4 million centimeters. But that's a terrible way to leave a number in science. I mean, we really want to convert this into scientific notation. First, it's really kind of silly to write down all those digits. So let's round the numerical part of the answer to 4.23. Now, let's see how many places I need to move the decimal point to write this as 4.23. Okay, that's 1, 2, 3, 4, 5, 6. I've got to move the decimal point 6 places to write that as 4.23. And that means that the exponential part of the answer will involve 10 raised to some power of 6. But the question, of course, is, should I make the exponent of 10 plus 6 or minus 6? I know I have to move the decimal point 6 places, but what is the exponent of 10? To answer this, all you have to do is ask yourself, is this a big number or a little number? Well, 4 million is obviously a big number, so I must multiply this by 10 to the 6th. I'd like to make another comment here. I previously mentioned that a good habit to get into is to try and mentally check your answer when you're finished, to try and see if an answer is, quote, reasonable. Now, on this marathon problem, I don't think it's easy to mentally decide whether an answer is somewhat larger than 4 million or smaller than 4 million or whatever, as opposed to an answer like 2 million centimeters or 6 million or something else. But if we made an exponent error and said the answer was a very small number, we should immediately see that that doesn't make any sense. The answer has to be a very large number, although it may, as we said, be difficult to estimate what that number exactly might be. But any small number has to be incorrect. Now let's look at another problem on the screen. Now remember, you have to be trying these problems. Remember the old saying, don't try this at home? Well, here you do try this at home. Convert 60 miles per hour to meters per second using the conversion factors you see on the screen, but not necessarily in the order given. This turns out to be a rather involved problem. I am supposed to convert 60 miles per hour into a metric unit, namely meters per second. Sometimes students will get confused and ask something like, now how am I going to convert meters and seconds and hours and all this at the same time? You're not. What you really have here are two separate problems that are kind of linked. The separate problems are, one, you're going to have to convert miles into meters, and two, you're going to have to convert per hour into per second. And each of these two factors can be dealt with totally independently of the other factor. After we convert miles into meters, then we'll work on converting per hour into per second. It works like this. Let's convert the miles into meters. Like I said in an earlier problem, it would be wonderful if I had a conversion factor that told me how many meters there were in 1 mile. Unfortunately, using the conversion factors that you were given, you don't have that information. What this means is that you're going to have to use multiple factors. How do you decide what these factors are? You look at the ones that you're given. Obviously, if I'm going to cancel out miles, I have to use a factor that has miles in it. The only factor you were given that had miles in it was that there were 5,280 feet per mile. So that has to be the first factor I use. That will cancel out miles, and now my answer is in feet. But that's not what I wanted. I didn't want the answer in feet. I wanted the answer in meters. So now what do we have to do? Well, I'll have to get rid of the feet. So what factor has feet in it? That factor is 12 inches per foot. Foot, which can be considered the same as feet, goes in the denominator, so it cancels out. Inches goes in the numerator, and the factor is 12 inches per foot. Now I have my answer in inches, but that's still not what I want. I've got to get rid of the inches, and the factor that has inches in it is 2.54 centimeters per inch. Now my answer is in centimeters, but I was supposed to get the answer in meters. Let's cancel out the centimeters and let's replace it with meters. That conversion factor is 1 meter is equal to 100 centimeters. You notice that in this case, the big number went in the denominator. Now I have completed the first part of the problem. I've gotten rid of the miles and I've replaced it by meters. Now I have to convert the per hour into per second. Watch carefully because this is a bit trickier. One reason is almost psychological. The next factor is physically so far away from the factor that it's relating to. Oddly enough, this sometimes can cause a few students difficulty. But obviously, the physical distance between the factors when you write them out is irrelevant. Since hours is in the denominator, I'm going to have to use a factor that has hours in the numerator. Then hours will cancel out. The only conversion factor you were given that had hours in it was 60 minutes equals 1 hour. So the actual factor in this solution would be 1 hour over 60 minutes. If you do that, now you have your answer in per minute. But that wasn't good enough. We needed to get our answer in units of per second. So now we're going to need one more factor. A factor that has units of minutes in the numerator, so minutes cancels out, and seconds in the denominator. This factor is 1 minute over 60 seconds. Now I have a rather impressive solution written out. I think it's always a good idea to leave something like this on your desk at home. When your parents walk by and see it, then, if you come home and bring a D home or something like that, it doesn't look so bad. This thing looks like something Einstein must have been working on when he died. Now, all I have to do is take out a calculator, thank heavens for that. If you punch in all the numbers correctly, you will obtain an answer of about 26.8 meters per second. Now let's try a problem that's a bit tricky. So before you do this, think and think carefully. I'll tell you ahead of time that I would be quite amazed if you were able to solve this correctly the first time. Very few students do. Convert 1 cubic inch to cubic centimeters. Now you may very well look at this problem and think, why did he say this was tricky? It looks pretty simple to me. If I want to convert 1 cubic inch to cubic centimeters, all I have to do is multiply by a factor that has inches in the denominator and centimeters in the numerator. And that's 2.54 centimeters per 1 inch. So what's the big deal? I know the answer. It must be 2.54 cubic centimeters. That's the error noise. Wrong. What's wrong here is that you didn't convert cubic inches into cubic centimeters. Inches do not cancel out cubic inches. There are not 2.54 cubic centimeters for 1 cubic inch. Let's take a look at this on a graphic. Here's a box that represents 1 cubic inch. 1 inch is the same as 2.54 centimeters. So this box is 1 inch on a side or 2.54 centimeters on a side. 2.54 centimeters times 2.54 centimeters times 2.54 centimeters is a volume of 2.54 centimeters cubed, or 16.4 cubic centimeters. Now, if you want, you can draw this box and think of this problem this way. But you can also do this by just analyzing units. You already have the conversion factor 2.54 centimeters per 1 inch. How do you transform this so it contains cubic inches, which is a unit that must be canceled out? Simple. Just cube the factor. So the factor that converts cubic inches to cubic centimeters would just be 2.54 centimeters over 1 inch, quantity cubed. Inches cubed will cancel inches cubed, and the number is not 2.54, but is 2.54 cubed, or 16.4. In the next 3 lectures, we're going to move away from the pure problem solving just for a while and cover some basic information that should probably be talked about before we proceed much further.